weak base. Weak base, or we say high. Sorry. That is low alkalinity. That is weak base. And then finally pH from 11 to 14 implies high alkalinity. That is strong base. Okay, so this is a summary of the pH scale. As I say, it ranges from 0 to 14. If a pH value reads between 0 and 3, it means that that pH value is high acidity, which implies that the solution is a strong acid. If the pH is from 4 to 6, it indicates low acidity. It means that the solution is a weak acid. If it is equal to 7, that means that the solution is neutral. If it is from 8 to 10, it shows low alkalinity. That means the solution is a weak base. And finally, if it ranges from 11 to 14, then indicates high alkalinity or high basicity, which indicate that the solution is a strong base. Okay, so based on this, we're going to look at the question 4. It says, Fig 2 or the figure below is an illustration of the pH values x1, x2, x3, x4, and x5 of 5 different solutions on the pH scale. So the solutions are vinegar, distilled water, solution of plant ashes, dilute nitric acid, and ammonia solution. It says study the illustration carefully and answer the questions that follow. So you have the diagram, and under the diagram, the A is asking to read and record each of the values x1, x2, up to x5. So quickly, let's look at the A, question A. A. You are supposed to read and record the pH values x1, x2, x3, x4, and then x5. Now from the diagram, you are supposed to know the value of each of the smaller divisions. And the first two major values indicated on the diagram is 0 and 2. If you take the 0 and 2, if you count the smaller divisions between them, you get 10. So how do we get the value of each smaller division? It will be the 2 minus 0 over the 10. That will give you 2 on 10, which is 0.2. So it means that each of the smaller division there is 0.2. Is 0.2. Okay, so let's go back to the diagram. The x1 is pointing to, if you do the counting, that is 1, 2, 3, 4, 5, 6. The sixth division. That is the C division after 0. So you just multiply by E division, which is 0.2. So that will give you 1.2. 1.2. Okay, so you require it to 2 decimal places, so that's 1.2. You know, a pH value has no units, so 1.2. Now, the x2 is pointing to the second division after 4. So the second division, that's 2. If you use to multiply 0.2, that will give you 0.4. It's coming after 4, so you add it to the 4, that will be 4.4. Okay. 4.4. X3 is pointing to the fifth division after 6. So if you do the counting, that will give you 5 times 0.2 is 1. If you add it to the 6, that will give you 7. So that is 7.00. And then the x4 is pointing to the 9th division after 8. 9th division after 8. If you add the 9 times the 0.2 will give you 1.8. If you add a 1.8 to the 8, that will give you 9.8. And then finally, the x5 is also pointing to the 9th division after the 12th. So just like the x4, 9 division after 12. So you multiply the 9 by 0.2, that is 1.8. You add it to the 12, that gives you 13.8. So these are the pH values as indicated in the diagram. Okay, quickly let's look at the B. The B is asking that you pair each of the pH values with the appropriate solutions. So some solutions were mentioned in the preamble. They are the vinegar, distilled water, solution of plant ashes, dilute nitric acid, and ammonia solution. So you are going to pair those solutions with the pH values indicated. It is for you to know whether each of the solutions given is a strong acid, whether it's a strong base, whether it's a weak acid, whether it is a weak base, or whether it is a neutral solution. So these values are giving you the implication of each solution as I've described here earlier on. So if you have a value of 1.2, 1.2 falls between 0 and 3. It means that that solution should be a strong acid. If you have a value of 4.40, it falls between 4 and 6. It means that that solution is a weak acid. And then if the value is 7, it means that that solution is a neutral solution. And a value of 9.80 falls between 8 and 10. So it implies that that solution has to be a weak base. And then the last one, 13.80, falls between 11 and 40. It means that that solution should be a strong base. So if you compare the solutions given, vinegar contains what we call acetic acid, which is a weak acid. So the vinegar there is a weak acid. Distilled water is a neutral solution. It is neutral. It is neither acidic nor basic. And then solution of plant ashes. If you recall what we did under organic chemistry when we were looking at saponification, the traditional preparation also, or the indigenous way of preparing local soup, we said that the base that is used in the preparation of the soup comes from the ashes of plantain peels, coconut husk, and the likes. So if you are talking of solution of plant ashes, that contains a base. I told you that the base contains either sodium hydroxide or potassium hydroxide. And potassium hydroxide, sodium hydroxide are strong bases. So solution of plant ashes is a strong base. Nitric acid, that is HNO3, is a strong acid. And ammonia solution is a base, but then this is a weak base. Okay, so we are going to pair them up. So B pair each pH value to with the appropriate solution. So for X1 indicates a strong acid. So as I said, the strong acid there is the nitric acid. So that is a dilute nitric acid. Your X2. The X2 value shows a weak acid. And the weak acid there is a vinegar. X3. The value of X3 indicates neutral solution. The neutral solution there is distilled water. X4 indicates a weak base, and the weak base there is the ammonia solution. And finally, X5 implies or indicates a strong base, and the strong base there is a solution of plant ashes. Okay, so that is for B. Now the C is asking you to tabulate your data as shown below. So you are just redrawing the table indicated in C, and then the information you had in A and B, you put it in the C. So you have this table. You have pH value, and then you have solution. So for X1, say X1 is dilute nitric acid. X2 is vinegar. X3 is distilled water. X4, ammonia solution. And then X5, solution of plant ashes. Okay, so that is for the C. So all that you're doing is you are reproducing the information A and B, and then you are putting it in the table. And then the D, question D is asking that you give a reason for each pair of pH value and solution. I think I've explained this earlier on. So why are you saying that the value 1.20, which is X1, is for dilute nitric acid? I'm saying so because the value 1.20 indicates high acidity, and so the solution has to be a strong acid. So for X1, so X1, X2, S3, X4, X5. Okay, so for X1, it shows strong acid. This weak acid. As I said, you can say this high acidity. And this low acidity. Your X3 is neutral. Neutral solution. Your S4 is weak base. And then finally, the last one is strong base. So that is for question 4. So that ends question 4. That ends question 4.